We're going to take a look at how we can calculate the amount if we are making more than one payment. So we're going to take a look at annuities. And an annuity is where we're making a series of equal payments at regular time intervals. So might be at the end of every month we put $100 in. It might be at the end of every 6 months we put $500 in. But we're making a series of regular payments, and we want to be able to figure out how much we have in that investment at the end. So what we are going to do, and just to let you know, an ordinary annuity is when the payments are made at the end of the time period. So our formula for the amount of a regular annuity is still calculating A for our amount, and we're going to have R times 1 plus I to the power of n minus 1, all divided by I. And remember that R is the regular payment. So what are we putting into that account? I is our interest rate per period, just like we did for a single payment. And N is the number of compounding periods, which simply means how many times a year times the number of years is interest compounded. Number of compounding periods. So example number 1, Connie deposits $100 at the end of each month, and this is where you notice that this is an annuity. So when it's an annuity, it will say $100 at the end of every time period, at the end of the month, at the end of every 6 months. So this account pays 6% per annum compounded monthly, and we want to find the amount after 1 year. So we're going to take our formula, and we're going to sub in what we know. So $100, our interest rate is 0.06, but remember that we have to divide that by 12 because we're talking about compounding monthly, so we need the interest rate per month. And on the bottom we have I as well, which means that we're going to have 0.06 divided by 12. So we're going to simplify what we have here. So inside our brackets, we're going to have 1.005. Oops, sorry, and I missed our n here. So we're just 12 times per year for 1 year. So we'll have 1.005 to the power of 12, subtract 1, divided by 0.005. And we can do that all in the calculator in one big step. 1.005 to the power of 12 minus 1 equals times 100 and divided by 0.005. When we do that, we get 1,233.56. So Connie will have $1,233.56 in 1 year. Now, how much interest did she earn? So interest is still our difference between our amount and what we put in. Now, in this case, though, we have to keep in mind our amount is $1,233.56, but we didn't just put $100 in. we put $100 in 12 times. So we're going to have 1,233.56 minus 1,200, which means that the interest is $33.56. Okay, so when we have an annuity, we have to remember that we have to take into account all the payments that were put in. Example number 2, we're going to find the amount of each investment. And in this case, they are annuities still. So $2,000 deposit at the end of each year for 15 years at 6.4% compounded annually. So again, still starting with our formula. And subbing in. So our regular payment, $2,000. Our interest rate is 0.064 compounded annually. So that means that it's ultimately not going to change our I and our N because it is just happening once a year. Okay, so again, we can simplify. We're going to have 1.064 to the power of 15 minus 1 over 0.064. And when we do that, we get $47,995.47. Okay, so the amount with our dollar signs and our 2 decimal places for dollars and cents, $47,995.47. Second one, we have $500 deposit at the end of each 6 months. Okay, so again, there's what tells us it's an annuity at the end of each 6 months. For 20 years, 6.85%. And it's compounded semi-annually. So again, semi-annually means every half year or twice a year. So we're going to have 500. Our interest rate is 0.0685, but we have to divide that by 2. And our N, we're going to multiply 20 times 2. Okay, now we can still do this all in one huge step in our calculator. We just have to be careful that we pay attention to our steps. So we're going to take 0.0685 divided by 2 equals plus 1, gives us the answer to the inside bracket, to the power of 40 equals, then we're going to subtract 1. This gives us the answer for the big bracket. Now we're going to multiply that by 500 equals, and then when we divide, we're just going to make sure that we put our 0.0685 divided by 2 in brackets. So divided by bracket, 0.0685 divided by 2, end bracket, and equals. And when we do that, we should get 41,548.98. So the amount is $41,548.98. And again, if we were looking for interest, we would take away our 40 payments of $500 to see how much was gained in interest. So it's always the difference between what came out of the